Okay, we're going to pick up here with the Pythagorean identities. So if you look at the top of your sheet where they have the fundamental identities, this is one that we did not look at yet. There's three of them. And this is kind of the main one, sine squared of theta plus cosine squared of theta equals 1. But what we're going to do, I'm going to show you how it's very easy to develop the other two that go along with this. If you put this in your head, and it's pretty easy to memorize this one. If you take this identity and you go through and you divide both sides of this equation by sine squared. What you get is sine squared divided by sine squared is 1. Cosine over sine is cotangent. And cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. So this is another one of the identities. You can memorize this identity or you can develop it either way. If you take sine squared plus cosine squared is 1, and you go through this identity and divide both sides by cosine squared. Sine divided by cosine is tangent, and sine squared divided by cosine squared is tangent squared. Cosine divided by cosine is 1. 1 over cosine is secant, and 1 over cosine squared is secant squared. So these are the three Pythagorean identities. And so that's an easy way to develop those if you select not to just memorize those. Now, what we need to be familiar with is these identities, though. And so you may have some problem where they're like, hey, what is this equal to? Cosecant, what if they said, what is this equal to? Cosecant, come on. Cosecant squared minus 1. What does that equal to? Well, they might have you select different things, but we can see that if we take 1 and subtract this over here, that this would equal to cotangent squared. Or for instance, what if they say, what is, let's see, secant squared minus tangent squared? They might say, what does that equal to? Well, we can see here, if we subtract tangent from both sides, that this would just equal to 1, right? Or if they say, what is 1 minus cosine squared of theta? Well, 1, if I subtract cosine squared from both sides of this is equal to sine squared of theta. So sometimes there are manipulations of this Pythagorean identity that we need to be familiar with. Okay, now we're going to use our newfound knowledge of these other trig functions, and we're going to fill out this the bottom half of the sheet. But before we do that, we're going to fill in the unit circle. So I'm just going to do this. You may want to fast forward the video or pause the video and do this on your own. But I'm going to say this is quadrant 1. In quadrant 1, x is positive, y is positive. And all I'm going to do is fill this out for quadrant 1 and then use this information to do the rest. But before I do that, I'm going to go through and label all my important angles. If you do what I'm about to do here 2 or 3 times on your own, you will have this in your head for life, and it's going to serve you well in all of your other math classes. This is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And then this is also called 360 degrees. And then the important angles go by 30. So this is 30. Skip the middle one. This is 60. Plus another 30 is 90. Plus another 30 is 120. 150. 180. 210, 240, 270, 300, 330, and then 360. Okay. The other important angles are 45. So this is 45 plus another 45 is 90 plus another 45 is 135 plus another 45 lands here plus another 45 lands here. 225 plus another 45 is here plus another 45 is here. 315 plus another 45 is there. Now we can go through and do this in radians, and we should. So 30 degrees in radians you can convert by multiplying by pi over 180, and you will simplify and you'll find that this is pi over 6. So this is 0 radians. Before I do the pi over 6, let's go. 90 degrees you can convert, but this is going to be pi over 2 plus another pi over 2 is pi plus another pi over 2 is 3 pi over 2 plus another pi over 2 is 2 pi. Okay. Now 30 degrees. If we go around, 30 degrees is 1 pi over 6. 2 pi over 6 can simplify to pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 can simplify to 2 pi over 3. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 simplifies to 4 pi over 3. 9 pi over 6 simplifies to 3 pi over 2. 10 pi over 6 simplifies to 5 pi over 3. And this is 11 pi over 6. So there's the equivalent in radian form. And then let's do the 45s. 45 degrees, you can convert that by multiplying by pi over 180. And that will give you pi over 4. Plus another pi over 4 is pi over 2. Plus another pi over 4 is 3 pi over 4. Plus another pi over 4 is 4 pi over 4, which is pi. Plus another pi over 4 is 5 pi over 4. Plus another pi over 4 is 3 pi over 2 once it's simplified. Another pi over 4 is 7 pi over 4. Plus another pi over 4 is 8 pi over 4, which is another name for 2 pi. Then we can go ahead and fill in our coordinates, okay? This is the unit circle. 1 unit to the right has the coordinates 1, 0. 1 unit up the y-axis have the coordinate 0, 1. At pi, this is 1 unit to the left, -1, 0 on the x-axis. At 3 pi over 2 or 270s, this is 1 unit down on the y-axis. So this is 0, -1. So if we remember, and we should, that sine on the unit circle, sine of some angle is associated with the y value, and the cosine of some angle is associated with the x value. So what I mean by that is if somebody says, what is the sine of 3 pi over 2? I find my angle 3 pi over 2, and I say that the sine is the y value. It is -1. But what we're about to do is call it out for any of the other trig functions. So if somebody comes and says, hey, what is the secant of pi over 6? Well, I know that secant is really 1 over the cosine. And I know that cosine is the x value. So pi over 6 is here. Oh, so I better know what this is. All right, well, the sine of 30, I decided to memorize that one. And if I didn't memorize it, I could draw my little reference angle and say this is 30 degrees. And I could remember my little triangle. And so this is 1 over 2. But this is the unit circle. You could do it using special triangles, or you can memorize it. I chose to memorize this one because it's faster to fill this out. So the sine of 30 is 1/2. So this is the y value, 1/2. All right. Let me write that so there's not too many. Let me write it above the line. It's 1/2. And on my 30, 60, 90 triangle, if this is 30, let's say this is 30. This is 1/2. And this is square root of 3 over 2. So the cosine is square root of 3 over 2. Square root of 3 over 2. Well, this is what I know. 1/2 and square root of 3 over 2 go together. And so right here at pi over 3 or at 60 degrees, the x value is small. The y value is big. So this is square root of 3 over 2. This little line is driving me nuts. I'm gonna write this so that it doesn't look so bad. All right. So this is the square root of 3 over 2. This is going to be 1/2 here and the square root of 3 over 2. All right. Knowing that, I can fill out all of these. Let's see. Let's do this guy right here. This was the big X, so that's square root of 3 over 2. This is the small y, that's a 1/2. This point right here, this is the small x, so that's a 1/2. This is a tall y, the big one, square root of 3 over 2. But we're in quadrant 2, where x is negative and y is positive. So my x's are going to be negative. Let's go down here to quadrant 3, where both are negative. I'll throw in the negative signs at the end. X is big, so this is the square root of 3 over 2. Y is small. This is 1/2. They're both negative. This point right here, x is small. This is a 1/2. Y is longer, square root of 3 over 2. These are both negative. Now you can do what I'm doing, or you can draw the reference angle. This would be 60 degrees, and you could do your little reference triangle in there for all of these. You could do that. Over here, let's do this one. X is small, Y is big. X is small, that's the 1/2. Y is big, well, this is the square root of 3 over 2. But we're in quadrant 4 where X is positive and Y is negative. I'm going to make my Y's negative. Right here, X is big, square root of 3 over 2. Y is small, 1/2, but this is going to be negative. So let me make sure I'm happy with my signs. Positive, positive, negative, positive, negative, 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 negative. Okay. Also, I'm going to make sure I like my values. If I were to fold this across, the square root of 3's and the 1/2 should line up in the same places. I'm just double checking everything. I like that. The only thing left to fill in is the 45s or the pi over 4. That is the 45, 45, 90 special triangle. I have put this in my head that it's 1 over the square root of 2 for both of the values. This is always going to be 1 over the square root of 2, which incidentally, just in case I haven't mentioned this before, 1 over the square root of 2, if you rationalize this, 1 times the square root of 2 is 2. The square root of 2 times the square root of 2 is the square root of 4, which is 2. So if some of you guys are like, why is she writing that? I saw the unit circle and it's the square root of 2 over 2. The 1 over the square root of 2 and the square root of 2 over 2 are the same value. Mine's just not rationalized. So don't let that bother you too much. Over here, we're going to make the x value negative. Here, negative 1 over the square root of 2, negative 1 over the square root of 2. Over here, 1 over the square root of 2, negative 1 over the square root of 2. Okay, now our unit circle's filled in. I recommend that you be able to fill it in about that fast or a little bit slower, but not take too long to do it. Then you can answer whatever they ask you. So here we go. The sine of negative 120 degrees. Uh-oh, a negative angle. What do? We go clockwise 120 degrees. So if 120 degrees is 90 plus another 30, then negative 120 degrees will be this way, 90 plus another 120, or it's coterminal with 240. The sine of that is the y value. So this is going to be negative square root of 3 over 2. The tangent of negative pi over 3. All right. If pi over 3 is this far positive, then negative pi over 3 would be this far. We'd go down pi over 3 clockwise. And the tangent is sine over cosine. So the tangent is negative square root of 3 over 2 divided by 1/2. You can do a keep, change, flip, and simplify this. And this will be simply negative the square root of 3 once you get done with that. Now, the cosecant of negative pi over 6. Okay, pi over 6 is this far. Negative pi over 6 is this far. The cotangent of negative pi over 6 would be 1 over the sine of negative pi over 6. Okay, well, the sine of negative pi over 6, which is coterminal with 11 pi over 6, would be 1 over negative 1/2, which was going to be negative 2 if you do a keep, change, flip. All right, the cotangent of 3 pi over 4. Well, where's 3 pi over 4? Here it is. And the cotangent will be the cosine over the sine, or 1 over, the cosine over the sine, or 1 over the tangent. If you take the cosine, negative 1 over the square root of 2 divided by 1 over the square root of 2, you're going to get a negative 1. The sine of negative 3 pi over 2. All right, negative 3 pi over 2. Ready? We're going to go around the unit circle clockwise, and that gives us negative 2 pi, and negative 3 pi would be another negative pi. So we're going to index coterminal with pi. What is the sign of this? It's going to be the y value. It's going to be 0. The cosecant of negative 180. Okay, negative 180 will be clockwise direction 180. So it's right here. And the cosecant is 1 over the sine. 1 over the sine was 1 over 0. This is undefined because you can't divide by 0. Let's do number 3. The secant of negative pi over 6. Negative pi over 6 would be clockwise pi over 6. So it's 11 pi over 6. The secant is 1 over the cosine. 1 over the square root of 3 over 2 will be 2 over the square root of 3. The cosine of negative 120. This is negative 90. This is negative 120. It's coterminal with 240. The cosine of this is going to be negative 1/2. The cotangent of negative pi over 3. I don't know why I was doing all these negative angles, but here we go. The cotangent of negative pi over 3 will be clockwise. Pi over 3, coterminal with 5 pi over 3. The cotangent is cosine over sine. 1/2 divided by negative square root of 3 over 2 is going to do a keep, change, flip. It will be negative 1 over the square root of 3. Or if you rationalize this, this will be negative square root of 3 over 3. 720, where is that? Okay, ready? This is 360 plus another 360 is 720. 720 is coterminal with 0 degrees. The cosecant will be 1 over the sine. The sine is the y value, 0. So 1 over 0 is undefined. That's what we get for that. The tangent of positive 3 pi over 4. 3 pi over 4 is here. The tangent is 1 over the square root of 2 divided by negative 1 over the square root of 2, which is going to give me a negative 1. The cosine of negative 3 pi. Okay, this is clockwise. That's negative 2 pi. Negative 3 pi is coterminal with pi. And the cosine of that is simply the x value. So that is also a negative 1 right here. All right. So that is how you can use your unit circle. We're going to get our calculator out and we're going to do this last part. Okay, so the last part is the sine of 30, the sine in degrees. So I have a mix of degrees and radians. And this time I wrote out RAD for radians, but they don't always do that. So this is also in radians, and this is also in radians, and this is also in radians, and this is also in radians, even when they don't write RAD. So what we're going to do is get our calculator out and turn it on. Oh no, my batteries are dead. Okay, I'm gonna have to pause this and get new batteries. Okay, now I have some new batteries. So what we want to do is make sure we're in the right mode. So if we're in degree mode, that's what I'm going to do first. On my calculator, if you hit mode, it's going to show you what mode your calculator's in. Mine is currently in degree because degree is highlighted. See, if I wanted it in radian, I would highlight radian and hit enter. And then it's going to be in radian, but I don't. I'm going to start in degree. So I want it to be in degree. So once you select that, then you can hit second quit and it'll get out of that mode button. And now I know I'm in degrees. And so I'm going to do the sine of 30 degrees, but I know that's 1/2. So I know I should get 0.5. If I don't, I'm going to check my settings. Hit sine right there and put 30 degrees in. All right. And when we do that, we get 0.5, which is what I was expecting. So that makes me happy. It says evaluate to 3 decimal places. So technically I should say 0.500. Now I want to do the cosine of 38.27. So I hit cosine and I say 38.27. And to 3 places will be 0.785, 0.785. And then this is radians, this is radians, this is radians, this is radians. I'm not going to do that because I'm in degree mode. Let's do some more degrees. The cosine of 30, the cosine of 30 is the square root of 3/2. But what is that in decimal? It is 0.866. The cotangent of 49.82. Look at my calculator. I do not have a cotangent button. I have a sine, cosine, and a tangent button. So I got to know that the cotangent of any angle is 1 divided by the tangent. So what I'm going to do is say 1 divided by the tangent of 49.82, and that's how I can get the cotangent of that. And this is going to be 0.844. Let's go through. That was all my degrees. Now I need to be in radians. So I'm going to go to mode. I'm going to go down to radians and hit enter. And now I'm going to take the sine of 30, and I should not get 0.5 because 30 radians means, if you recall, that one trip around the circle is about, this is about 2 pi, this is 2 pi, which is 6.28. So another one's going to be like 12.6 about. And another one is another 6.28. So the sine of 30 is about 5 or so trips around the circle. So I should get a different value for this sine of 30 than I did with degrees. The sine of 30 radians gives me negative 0.988. Negative 0.988. The sine of 37 is negative 0.64, and I should round up to 4. Negative 0.644. Okay, the tangent of 15, radians is negative 0.856. When I round it, negative 0.856. And now let's handle the cosecant of 0.25. All right, the cosecant of 2.5 is equal to 1 over the sine of 2.5. So that's what I have to do. I'm going to say 1 divided by the sine of 2.5. And that gives me 1 point, if we want to 3 decimal places, it's going to be 1.671. And then the cotangent of 64, again, I have to say 1 divided by the tangent because I don't have a cotangent button. So it's going to be 1. Uh-oh. Oh, no, no, no. Don't do this to me. It died right there on me. Don't do that to me. Ah, hang on. Okay, so we're going to take 1 divided by the sine of 2.5, although I gotta check my settings because, oh, did I just do that? Oh, no, I was doing this one. Sorry. The 1 divided by the tangent of 64 radians is going to be the cotangent of 64. So this is 0.426. 0.426. All right. That is how you can use your calculator, and that is how you can calculate these guys.